Hey everyone, in this video I'll be showing off these two projects in p5js. I'll show you how they work, going over all of the code. Before I get into the code, I want to give you some background and context. Note that there will be a bunch of links in the video description for everything that I talk about. Both projects are using MoveNet, a machine learning model that detects joints on your body. Someone fed the machine a ton of images of people with their joints labeled. This is a right shoulder. This is a left wrist. The program analyzes all this data and eventually it learns to detect where a joint or body part is when you show it a new image. MoveNet is developed by TensorFlow. These are the same people who made PoseNet, another machine learning model that detects body parts. If you're interested in machine learning and how you can use it with p5js, I suggest you check out the ML5 website and also check out this playlist by the Coding Train. The project with the balls, besides using MoveNet, also uses p5play, a physics and game engine library. I have a video introduction to p5play if you want to watch that, or you can just visit their website. If you've been a fan of the channel, you might remember that I've worked with PoseNet and p5play before. I'm using MoveNet this time because it works a lot better than PoseNet. PoseNet is jittery and MoveNet is fast and smooth. Also, I was using URL links to these libraries in the index, and unfortunately those projects aren't working anymore. Something got updated in one of these libraries and now PoseNet and p5play don't play nice together. So for today's project, I decided to download all the library files so that we don't need to worry about updates breaking things. Okay, now let's look at some code. We're going to start by just looking at MoveNet and what's needed to detect points. So first, I'll show you that there are some files over here that I downloaded. Here's posedetection.js, backend WebGL, converter, core, and so all of these are needed for the MoveNet to work. Now there's a bunch of stuff at the top that I'm not going to go over in detail. It's just copy pasted from the TensorFlow website. This async function init, pose detection, detector, the video ready, the get poses, and all of that is just saying, okay, start the MoveNet stuff, start the video, and start detecting poses. That's all that does. And the poses right here is an array of poses that it is detecting. So we start the video capture, and the video has to be a certain width and height in order to work with MoveNet. And then we call this await init, which is all that stuff at the top that I just told you about. And then we're going to be making the skeleton white with a stroke weight of 5, so a little bit thick so that you can see it. In the draw loop, we're going to show the video. We're going to draw the skeleton on top of the video, and I'll get to that in a minute. And then we have to flip everything horizontally, because if we don't, when I move this way, the video is going to be moving this way, and I want it to be a mirror. So this is grabbing the image on the screen, translating to the right side of the screen, scaling -1, 1, and that's going to flip everything to the other side, and then showing that image that we captured here, but now it's flipped. So what is this draw skeleton? Well, we're going to be looking at all of the poses that we're detecting, and we're going to get key points from those poses. Each joint, or the nose, the eyes, the ears, all of those have certain key points. So I've got those down here. Nose is 0 key point, left eye is key point number 1, etc. So to make the line that's going to go from shoulder to shoulder, one shoulder is key point 5 and the other shoulder is key point 6. So we're going to say that key point 5 is part A and key point 6 is part B. And then we need to look at a score. So every time it's detecting a pose, it's got a confidence of certain amount. And so we want to make sure that it's fairly confident in order to use that pose detection. So we're only going to use that pose detection if the score is greater than 0.1. If the pose detection for both parts are greater than 0.1, now we're going to draw a line from part A, the x of part A, and the y of part A, to the x of part B and the y of part B. And that's basically it. We do that for the shoulder, we do that for the hips. We've got one shoulder to one hip and the other shoulder to the other hip. We've got a hip to the foot, and up here we've got the shoulder to the wrist. So that's all there is to the drawing of the skeleton. Now let's look at MoveNet and using the body detection to make a flow field. Now I've had a video about making an animated flow field. I'll leave a link to that video in the video description. Everything is here that was in the skeleton code that I just showed you. There's a couple of additional things at the top, lines and lines 2 arrays that we're going to get started. I've got this variable height2, which is height divided by 2, because I'm dividing the canvas up into one part that's going to show the result, the flow field body, and a bottom part that's going to show the video. I've got a buffer canvas here being created, and that canvas is going to be where the skeleton gets drawn. So I'm drawing the same skeleton that I was in the previous code, but this skeleton is going to have very thick limbs. So you can see here that I've got a stroke weight of 40. For the flow field, we're going to be drawing 300 lines at a time, and each line is going to be made up of a bunch of segments. It's going to have 10 segments. So this is the max age here is 10. We're also going to be using Perlin noise, so I've got a resolution here of 0.003. The Perlin noise is animated, so instead of just using an x times res and a y times res, we also are going to have a z component to help with that animation so that the noise doesn't stay the same all the time. For the line segments, each line segment is going to be width times 0.01, and we're going to start off with those 300 lines, pushing them into this lines array. We're going to be pushing in a random x location, random y, the age. We're going to start by just having a random age, and we're going to be putting in a color. Just to start with, I'm putting in a blue color, but that will be overridden very quickly. So now we're in our draw loop. I have a counter in here, and it's only going to start drawing the skeleton if we get up to 5. I don't know if it was necessary for the project, but that's what I did. I'm drawing the skeleton, but if we look at the draw skeleton, you'll see that it's drawing on that buffer canvas, CNV. Now I do have this other one here, but this is actually only going to be drawn if I show it. I've got this variable show. So if I show it, it'll be drawn on the regular canvas. Otherwise, it'll only be drawn on the buffer canvas. So we draw the skeleton on that buffer canvas, and then we're going to flip the skeleton image on the buffer canvas. So I already talked about how to flip an image, so that's what we're doing here. Then we're going to call a makeLines function. So let's go look at that. We're going to go through the entire lines array, and the entire lines array, there are 300 lines, but each line has 4 components, so it's really 1,200 items in the lines array. And we're going to be pulling out the information out of the lines array, the old x, the old y, the age of the line, the color of the line, and then we're going to be adding 1 to the age. We're going to get a noise value for the old x and the old y. We'll map that to between 0 and pi times 2. So that's going to give us an angle determined by Perlin noise. Now we're going to get a new x and a new y based on that angle. Cosine of the angle times the length plus the old x equals our new x. The sine of the angle times the length plus the old y equals our new y. And now we draw a line between the old x and y and the new x and y. Now if that new x is greater than the width of the canvas or less than 0, or the new y is greater than the height of the canvas or less than 0, or the age is greater than the maximum age, then we're going to get a new point. So let's look at the new point function. The new point function is going to be coming up with an x and a y location that is on the skeleton on that buffer canvas. This is similar to what I've done with shape packing, checking a buffer canvas to see if there's a black or a white space in a certain location. First we start with saying open space is false. We'll have the age equal to 0 for this new point, and we're also going to need a counter because we're going to be looking for those new points, and I want to make sure that we don't get into an infinite loop because I'm going to be using a while loop, and there is danger of getting into an infinite loop when you use a while loop. So it's always good to have a counter when you use a while loop. So while the open space is false and the count to is less than 100, then we're going to do this stuff. So if count to gets to 100, then we're going to break out of our while loop. So first we're going to grab a random x and y from anywhere on the canvas, but now we have to check that x and y to see if it's on the body. So we grab the color of the pixel from that x and y off the buffer canvas. The skeleton is white. The background of the buffer canvas is black. I'm also going to get the color of the pixel from the video. This is where I'm grabbing the color of my shirt or my face. So I've got the new x, comma, the new y plus height 2 because the video is farther down. Then I check the pixel from the buffer canvas. If that pixel is 255, it's white, then open space is going to be true. So if open space is true, then we're done picking our new x and y, we break out of this while loop, and this function is done. But if it's black, then it doesn't say open space is true, which means it's false, and it continues trying to pick a new x and y. So let's go back to where new point was called. Here it is. And after that, either we've gotten a new point, or we're just using the new x and the new y from up here. Then we're going to push the new x and new y and the age and the color into the lines array. This is a new lines array. We've got the old lines array and the new lines array. I really should have called this lines new and lines old. Let's go ahead and do that right now. I'll replace that, test it again, make sure it works. Great, still works. So we are pushing the new x, new y, age, and color into the new lines array, lines new. Now we're taking the contents of the new lines array, putting that into the old lines array so that when we circle up to the top, we'll be grabbing from that array. And then when we do this, we're emptying the contents of the new lines array. And that's all there is to it. I add 2 here to the z so that the Perlin noise keeps changing. But that is it. Now let's move on to our next project, the one that is MoveNet plus p5play flow field with the balls. If we look at the files, you'll see that I've added the p5play.js and also this plankmin.js. I'm not sure if I needed that or not, but it's usually added along with p5play. And if we look at the index, you'll see that I'm referring to all of these files in the index. So looking at the sketch, this has the same variables as before. There are no lines arrays in this one, but there is an items array. This is all the same. We've got our setup. We start the video. All of this is about the same. I've got a size. That's going to be the size of the balls, width times 0.03. we have a new group. So the group is going to be the balls, and all of the balls are going to be red. So group is a function of the p5play library. The limbs are also going to be a new group. Now the balls are going to be on our regular canvas, and the limbs are going to be on our regular canvas, sort of. They're going to be invisible. See, I've got limbs.visible equals false. That again is a function of p5play. We're going to make 200 new balls. Those are called sprites in p5play. Each ball is going to have a random width, a random height, and that size 1. We're going to be drawing the limbs, but they're not going to be lines, they're going to be sprites. And the sprites in this case are going to be rectangles, and we don't want to just continually draw rectangle sprites, new sprites on the regular canvas. So every time draw starts, we're going to remove all of the limbs. So that's what the remove all is about. So then we're going to draw our skeleton. And if we look at the draw skeleton, this is all the same as it was before, except we're going to make sprite. So we're taking the part A and the part B, and that's going to go to the make sprite function. So in the make sprite, I've got the part A and the part B, and I've got to calculate where the limbs are going to be drawn, how they're going to be drawn. So let's say it's detecting this shoulder, but the pose detection is not mirrored to me. It's going to be the opposite. So if I didn't flip the canvas at the end, if I turn this way, it would look like my figure on the screen is turning this way, right? But I want the sprite to be drawn in the right place. So if I turn in this direction, I want the sprite to be turned in this direction, not in this direction. So in order to do that, I'm taking the width minus the x of the part A, so that if it's detecting something here, the sprite is going to be drawn over here. So I need to emphasize that these sprites are going to be rectangles. They're going to be drawn at the center point of that rectangle. They're not lines. So I have to figure out the middle of that rectangle, how long that rectangle is, and what the angle of that rectangle is. So this part here, sprite X and sprite Y, is determining the middle part of that rectangle. I need to know the length of that rectangle that's going to be drawn, so I need to use the distance formula to get the distance from part A, X and Y, to part B, X and Y. And then I need to calculate the angle of that rectangle, and this is the formula to calculate an angle if you know two X and Y positions. The difference between the two Y's divided by the difference between the two X's, and take the arctangent of that, and that gives you an angle. So finally, I can create the sprite. The new limb is going to be at sprite X, sprite Y, the distance, that's the width of the rectangle, the length or thickness of the rectangle is just fixed at width times 0.05, and then I'm giving it a rotation equal to the angle that I calculated here. So that is my new sprite. And going back to drawing the skeleton, that is the last thing that happens in the drawing of the skeleton, is the making of the sprite. So now we go back to where the skeleton was called, right here. We're just at the beginning of the draw loop. We're also going to be flipping everything on the video, and now we're going to make our flow field. So the flow field is saying where the ball is going to go next. We're going to go through all of our items. We have 200 items, 200 balls. We're going to call the items I sprite, and we're going to grab the X and the Y from that sprite. Now we get a noise value for that X and Y location of that ball, and we calculate an angle from that noise value. This calculation of the angle is a little bit more involved than what I did in the last one, but we're going to get an angle And then we're going to do the same thing, getting a new x and y. Cosine of the angle times the size plus the old x. Sine of the angle times the size plus the old y. That gives us our new x and y. And then we're going to use this function from p5play, sprite move towards the new x and new y. And this 0.2 is basically the force of how much you're going to move towards the new x and the new y. Then if our ball goes off the side of the screen, we're going to overlap the ball. Now I've got it, instead of just greater than width and then the new number equal to 0, I didn't want the balls to just disappear when they got to the edge of the screen. So I have them going off the screen a little bit and then appearing a little bit off the screen on this side before they come on. And that's pretty much it, except for this code right here. The skeleton makes a rectangle out of my shoulders down to my hips. So basically my whole torso is one rectangle, but it's blank inside, and the balls were getting stuck inside my torso. So this code is basically saying if the ball is inside of my torso, then make the ball disappear and respawn it somewhere random on the canvas. And that is it. Let me play this one more time. All right. And you see them sort of disappear. I guess they're still getting caught a little bit down here, but mostly they disappear if they get into my torso. So that's it for today. As I said, links for everything I talked about, including the code, are going to be in the video description. If you like this video, you can give it a like, consider subscribing to the channel, ring the bell for notifications, comments. I love to read your comments. Thanks for watching. I'll see you in the next one. Bye.